Welcome to Lucid Mind Chemistry channel. In this video, I'll be solving Chemistry A-Levels multiple choice questions. Paper 12 from October-November 2021. For question timestamps and other useful information, please visit video description. Question number 1. Compound X consists of 40% carbon, 6.7% hydrogen and 53.3% oxygen by mass. What is the empirical formula of compound X? Now, in order to find empirical formula, we can take percentage as mass in grams. We have carbon, hydrogen and oxygen. Mass in grams of carbon is 40. For hydrogen it is 6.7 and for oxygen it is 53.3. First, let's convert mass in grams into moles, as we know that moles is equal to mass in grams divided by atomic mass. So 40 divided by 12 for carbon, hydrogen 6.7 divided by 1, for oxygen 53.3 divided by 16. So it comes equal to 3.33 for carbon, 6.7 moles for hydrogen and 3.33 moles for oxygen. Now dividing by the smallest value on all sides, we have 3.33 smallest value. So we can divide this to get simple ratio. So the ratio comes to be 1:2:1. It means that in empirical formula, carbon is 1, hydrogen is 2 and oxygen is 1. So it is CH2O. Correct answer is therefore A. Question 2. Which statement is correct? Part A, we have 1 grams of hydrogen gas containing this much atoms. B is helium gas. Then we have methane gas and carbon dioxide gas. We have to convert it into atoms. Hydrogen gas is in the form of H2. We have 1 grams. Let's first convert grams into moles. So as number of moles is equal to mass in grams divided by molecular mass or atomic mass. Mass in grams is 1 gram. Molecular mass of H2 is 2. So we have 0.5 number of moles of hydrogen. Now this 0.5 moles is of hydrogen molecules. It is not of hydrogen atoms, because in the question they have given hydrogen gas, which is a molecule. Now let's convert this into atoms. As we know that one molecule consists of 2 atoms. 2 atoms of hydrogen are present in one molecule of hydrogen. So for 0.5 moles, we have 1 mole of hydrogen atoms. Now let's convert this number of moles into atoms. As we know that Avogadro's constant consists of 6.02 exponential 23 particles per mole. In this case, these are atoms. So this one is wrong. Doing the same for part B, we have 4 grams of helium gas. Let's first convert into number of moles. Molecular mass of helium is 4, so 4 divided by 4, it comes equal to 1 mole. As helium is atom, so therefore it means these are 1 mole of helium atoms. Or converting it into Avogadro's constant, we have 6.02 exponential 23 atoms of helium. Again, this is incorrect. For part C, we have methane. Methane is CH4 and it is in the form of molecule. First finding the number of moles. Mass is 16 grams and molecular mass of carbon is 12, and for hydrogen it is 1. So 12 plus 4 hydrogen, it becomes 16. Again, we have 1 mole of methane molecules. As we know that in one molecule of methane we have 5 atoms, 1 carbon and 4 hydrogen. So to convert this into atoms, we have 1 into 5 atoms in CH4. So we have 5 moles of atoms in CH4. Now converting these moles into number of atoms, we can multiply this by Avogadro's constant. 5 into 6 exponential 23. It comes equal to 3.0 exponential 24 atoms present in CH4. So this one seems to be correct. Now part D, 44 grams of carbon dioxide, again CO2 is a molecule. Converting mass into moles. Molecular mass of CO2 is 12 plus 32 equals 44. 44 grams divided by 44 molecular mass equals 1 mole of CO2 molecules. Now, as we know that in one molecule of carbon dioxide, we have 1 carbon atom and 2 oxygen atoms. So in total, we have 3 atoms in one molecule. So in 1 mole, we would have 3 moles of atoms in CO2. Now converting these moles into number of atoms, we can multiply this by Avogadro's constant. It comes equal to 18.02 exponential 23 atoms present in CO2. So this one is also wrong. Correct answer is therefore C. Question 3. Technetium Tc is a second row transition element that does not occur naturally on Earth. One of its isotope has 56 neutrons. What is the nucleon number of this isotope? We can find the atomic number of technetium from periodic table. It is equal to 43. As nucleon number means we have sum of protons and neutrons. So now we can add together. Number of protons is 43 according to periodic table. Number of neutrons is given, it is 56. So it comes equal to 99. Correct answer is therefore C. Question 4. Which atom has more unpaired electrons than paired electrons in orbitals of principal quantum number 2? We have carbon, whose atomic number is 6. We have nitrogen, atomic number is 7. For oxygen, it is 8, and for fluorine, it is 9. Let's do the electronic configuration. Carbon 6. We can do 1s2, 2s2, and in 2p, we have 3 orbitals, 2px, 2py, 2pz. As 2 electrons are left, so 1 will come in 2px, 1 will come in 2py. Now we have 2 unpaired electrons present in principal quantum number 2, and we have 1 paired electron present in principal quantum number 2. So unpaired, ratio paired, there are 2 unpaired electrons and 2 paired electrons. Doing the same for second one, nitrogen. 1s2, 2s2, again 2px, 2py, 2pz. 3 are left, so 1 in each suborbital. 3 unpaired electrons are present and 2 paired electrons are present. For oxygen, 1s2, 2s2, 2px, 2py, 2pz, 1, 2, 3 and 4 electrons. Now we can see we have 2 unpaired electrons and 4 paired electrons. For fluorine we can increase one more, 1s2, 2s2, 2px, 2py, 2pz, 4, 5, 6, 7, 8 and 9. Now we have just one unpaired electron and there are 6 electrons that are paired. So the only one in which unpaired electron is more than paired is nitrogen. Question 5. Atom X is the central atom in a molecule. In this molecule, atom X has 4 pairs of valence electrons in its outer shell. The 4 pairs of valence electron include at least one bond pair and at least one lone pair. What could be a possible shape for the molecule? Now we have atom X present in the form of molecule. Either we have 4 electron pairs around this one. Now among these pairs, at least one is bond pair and at least we have one lone pair. So there could be different possibilities. Let's suppose if we have 4 pairs of valence electrons, then we have different possibilities, such that first one is that all 4 are bond pairs. This is not possible because it says that it should at least have one lone pair. Second is that we have one lone pair and 3 bond pairs. Third possibility is that we have 2 lone pairs and 2 bond pairs. Or the fourth possibility is that we have 3 lone pairs and 1 bond pair. First one is incorrect, as we must have at least one lone pair and one bond pair. For second one, we have one lone pair and 3 bond pairs. This is possible in ammonia, as ammonia has one lone pair and there are 3 bond pairs that are bonded to 3 hydrogen atoms. Now the structure of ammonia is trigonal pyramidal. There is no such option given here. So we have second possibility, 2 lone pairs and 2 bond pairs. This is possible in the structure of water, as on oxygen we have 2 lone pairs and there are 2 bond pairs that are bonded to hydrogen. Now the structure of water is non-linear or bent structure. For third possibility, we have 3 lone pairs and 1 bond pair. Such molecule does not exist. Now the correct option should be B. Question 6. Which molecule has the largest overall dipole? Dipole means we have 2 sides, one is partial positive and second is partial negative. Let's look into the molecules. Chlorine is electronegative, so we have partial negative charges. Similarly in B, oxygen is electronegative. Hydrogen bears partial positive charge. Oxygen is electronegative, chlorine is electronegative. Now let's look into the symmetry of the molecule. As we can see that this molecule is perfectly symmetrical. as all bond angles are 120 degrees. So there is equal distribution of charges, partial negative charges on all sides, so therefore there is no dipole that is present. In part B, we can see that one portion is negative and the second portion of molecule is positive, so therefore this is not symmetric. So this will show the properties of dipole. On third one, we can see that we have 120 degree bond angle and all three sides are negative, so therefore this is symmetric distribution of negative charge. Again, in part D, we have 180 degree bond angle and on both sides we can see that partial negative charges are present. So therefore again this is symmetric distribution of charges and there is no dipole present. The only unsymmetrical molecule is CH2O and therefore this will show overall dipole. Question 7. The strength of hydrogen bonding increases as the electronegativity of the element bonded to hydrogen increases. Some information for a range of hydrides is given. We have PH3, HCl, HF, H2O and the boiling point increases down. Which statement and reason about these hydrides is correct? Part A, the boiling point of PH3 is much lower than the boiling point of water. We can see PH3 is 185 and water is 373. This is true because PH3 does not form hydrogen bonds or instantaneous dipole induced dipole forces between its molecules. For hydrogen bonding, we must have three elements directly attached to hydrogen. Either it should be fluorine or oxygen or nitrogen. So this part is correct that it does not form hydrogen bonds. For instantaneous dipole induced dipole forces, we can look into the structure of PH3. Phosphorus has 5 electrons in the outermost shell, out of which 1 is lone pair and 3 are bond pairs. As we can see that hydrogen is partial positive and this side is negative as we have lone pair of electrons. So therefore due to non-symmetric distribution of charges, it will be slightly polar and instantaneous dipole or induced dipole forces will be present. So this part is incorrect. Part B, the boiling point of HF is higher than the boiling point of HCl. Let's see this one. HF is higher than HCl because the bond energy of HF is greater than the bond energy of HCl. Now boiling point does not depend on bond energy, it depends on the intermolecular forces of attraction. So therefore this is incorrect. Part C, the boiling point of water is higher than the boiling point of HF. Water is 373, HF is 293. Because each hydrogen bond between the water molecule is stronger than each hydrogen bond between HF molecules. Now in the question, as they have given that more electronegative element means more stronger hydrogen bond. So hydrogen bonding between HF will be more strong as compared to hydrogen bonding between H and O. So the hydrogen bond between H2O molecule is weaker than the hydrogen bond between HF molecule. Part D, the boiling points of PH3 and HCl are similar. These are almost similar because the molecules of PH3 and HCl have the same number of electrons and similar molecular forces. Let's look into the number of electrons. Atomic number of phosphorus is 15. We have 3 hydrogens, so 15 plus 3 we have 18 electrons present. In HCl, the atomic number of hydrogen is 1. For chlorine it is 17, so 17 plus 1 we have 18 electrons that are present. So if we have same electron system and hydrogen is partial positive and chlorine is partial negative. So as the intermolecular forces are similar because the boiling point is almost same. Correct answer is therefore part D. Question 8. The general gas equation can be used to calculate the value of molecular mass of a gas for a sample of gas of mass m grams. Which expression will give the value of mR? We know the ideal gas equation. We have pressure into volume, or PV is equal to number of moles into ideal gas constant into temperature in Kelvin. We can also write this one as PV is equal to, as number of moles is equal to mass in grams divided by molecular mass. So we can write mass in grams divided by mR into R and T. Now we can rearrange to find out the value of mR. mR will be equal to mass in grams into R into T divided by pressure into volume. Correct expression is therefore given in A. Question 9. The equation for the formation of ammonium chloride is shown. Ammonia reacts with HCl to form ammonium chloride and enthalpy change is negative 314 kilojoules per mole. Which diagram shows the correctly labeled reaction pathway diagram for the decomposition of ammonium chloride? Now they have given the decomposition of ammonium chloride, which means that the reaction will be backward. And when the reaction is backward, the enthalpy change will reverse, so it will be plus 314 kilojoules per mole. And for reverse reaction, ammonium chloride will be the reactant and this side will be the product. We can also write this equation in order to understand ammonium chloride. We have ammonia and HCl. And this is the enthalpy change. Now as the enthalpy change is endothermic, so therefore the reactants must be at lower energy state and the product should be at higher energy state. This is because this much energy is being absorbed by the reactants to convert into products. So we can see that the energy of reactant is lower. Again we can see that the energy of reactant is lower than the product. In part C and D, we can see that the energy of reactant is higher, which is wrong. Second thing that we have to find out is whether the EA is correct or not. EA is activation energy, and activation energy is the energy required by the reactants to convert into the transition state. So the arrow should start over here till this place. This one is correct and this one is wrong. Third thing is the enthalpy change. Enthalpy change is the energy change between the energy of the reactants and the energy of product. As this is endothermic, so therefore the arrow should be upwards. So both are correct. Correct answer is therefore B. Question 10. In catalytic converter in the exhaust system of a car, carbon monoxide is oxidized to carbon dioxide and nitrogen monoxide is reduced to nitrogen. What are the changes in oxidation number of carbon and nitrogen in these two processes? We can write the equation. First one is carbon monoxide, which is oxidized to CO2. Second one is nitrogen monoxide, that is reduced to N2. As the oxidation state of oxygen is -2, so therefore for carbon it should be equal and opposite because there is no overall charge. For here we have two oxygen atoms, so it is -4 and carbon will be +4. Now the change is from +2 to +4, the change should be +2. Similarly, in nitrogen monoxide, oxygen is -2, so nitrogen must be +2. And in nitrogen molecule, the oxidation state is 0. So the change is -2. Correct answer is therefore D. Question 11. NO, nitrogen monoxide and nitrogen dioxide are both present in the lower atmosphere as pollutants. The reaction sequence shows the production of ozone from oxygen in the lower atmosphere. This sequence repeats many times. Which statement about this reaction sequence is correct? A. NO is acting as a catalyst, but NO2 is not acting as a catalyst. Now, catalyst is something that speeds up a chemical reaction without being used up, or it is reformed during the chemical reaction. Let's look into the catalyst. NO is acting as a catalyst. Now we can look at these reactions. This is reaction number 1, this is reaction number 2, and this is reaction number 3. Now let's suppose reaction 2 takes place first, as it is repeating many times. So NO will react with half oxygen to form NO2. Then on second step, NO2 will decompose to give NO and oxygen atom. As we can see that NO is unchanged in these chemical reactions as it is reproduced in the product. So therefore NO is acting as a catalyst. On second part it says NO2 is not acting as a catalyst. Now we can see that NO2 is the reactant in first reaction and it is the product in second reaction, so therefore it is unchanged. So NO2 is also acting as a catalyst. This is incorrect. NO2 is acting as a catalyst, but NO is not. Again, this is incorrect. Neither, both. Correct answer is therefore D. Question 12. A mixture of two period 3 oxides are added to water. A solution forms with a pH of just below 7. What could be the constituents of the mixture? In A we have aluminum oxide. Now aluminum oxide is insoluble. It does not affect the pH. Magnesium oxide is basic oxide as it is metal oxide that is slightly soluble. So overall the pH will increase as we have basic oxide present. In part B, we have sodium oxide. Again, this is metal oxide and highly soluble. It is basic. Magnesium oxide is also basic. So again, pH will be more than 7. It says this pH should be just below 7. So therefore, A and B both are incorrect. In part C, again, we have sodium oxide that is basic. And phosphorus oxide, as it is non-metal oxide, is acidic in nature. For part D, SO3 is acidic as it is non-metal oxide and it can form H2SO4. P4O10 is also acidic. It is also non-metal oxide and it can form H3PO4. So as both are strong acids, this one can form H2SO4 whose pH is almost equal to 1. This one can form H3PO4 in water whose pH is almost equal to 2. So overall pH will be between 1 and 2. It cannot be just below 7, so this is also incorrect. So now we can assume that P4O10 forms a little bit stronger acid as compared to the base that is formed or the alkali that is formed by sodium oxide. So therefore it will be slightly acidic. So part C could be correct option. Question 13. Which statement about the compounds of group 2 metals is correct? In part A we have stability of carbonates. In part B we have solubility of sulfates. In part C we have solubility of hydroxide, and in part D we have stability of nitrates. So for group 2 you should remember these. For carbonates, stability increases down the group. For nitrates, again stability increases down the group. This is the thermal stability. For hydroxides of group 2, solubility increases down the group. And last one is sulfates. The solubility of sulfates decrease down the group. Part A, barium carbonate is less thermally stable than strontium carbonate. As barium is below strontium, so the stability should increase and it should be more thermally stable. Part B, barium sulfate is less soluble than magnesium sulfate. Again, barium is below magnesium, so it should be less soluble as the solubility decreases. Part C, calcium hydroxide is less soluble than magnesium hydroxide. Calcium hydroxide is below magnesium hydroxide, so the solubility should increase and it should be more soluble. Part D, calcium nitrate is more thermally stable than strontium nitrate. As strontium is below calcium nitrate, so it should be more thermally stable than calcium nitrate. Calcium nitrate should be less thermally stable. Correct answer is therefore B. Question 14. A 0.005 mole sample of anhydrous calcium carbonate is completely thermally decomposed to give 100 cm3 of gas. In a separate experiment carried out under the same conditions, a 0.005 moles sample of anhydrous calcium nitrate is completely thermally decomposed. The volume of gaseous product is measured. What total volume of gaseous products is formed from the calcium nitrate? First one is calcium carbonate. We can use the equation CaCO3. It is thermally decomposed to form calcium oxide and the gas will be carbon dioxide. Now from balanced equation we can see that 1 mole of calcium carbonate, it forms 1 mole of carbon dioxide. So therefore 0.005 moles of calcium carbonate will form 0.005 moles of carbon dioxide gas. Now let's convert this moles into volume. We can multiply this by 24,000 to get centimeter cube. So it comes equal to 120 centimeter cube. As this one was the experiment, so therefore this is the actual value because it is less, and the theoretical value is 120 centimeter cube. The ratio between the actual value and theoretical value can be found out like this. We have 100 centimeter cube and 120. Now dividing by the smallest value on both sides, we can divide by 100. So the ratio between actual and theoretical is 1:1.2. Doing the same for second experiment, we have calcium nitrate, CaNO3 twice. It can be decomposed to form calcium oxide, that is solid. Then we have nitrogen dioxide, that is gas, and oxygen gas. Let's balance this chemical equation. We have 2 nitrogen atoms present on the right-hand side, so we can write 2. And we have 6 oxygen atoms, so 4, 5 and 6. We can do this one as half. Calcium is already balanced. So we can say that 1 mole of calcium nitrate decomposes to give 2 moles of nitrogen dioxide and half moles of oxygen gas. So therefore 0.005 moles of reactant will give double moles of nitrogen dioxide, so 2 into 0.005, and half moles of oxygen, so 0.005 divided by 2. This one comes equal to 0.01 and this one comes equal to 0.0025. So now the total number of moles of gaseous product formed will be, we can add them together. So therefore it will be equal to 0.0125 moles. Now let's convert these moles into volume. We can multiply it by 24,000 centimeter cube to convert it into centimeter cube. It comes equal to 300 centimeter cube. Now again, this is the theoretical value as it has been obtained from calculations. We have to find out the practical value or the actual value. Now theoretical value is more than actual value by ratio 1:1.2. So we can write actual, theoretical. If actual is 1, then theoretical is 1.2. And now theoretical is 300 centimeter cube, so actual can be obtained by cross multiplication. So it is equal to 250 centimeter cube. So this is the total volume of the gas that is produced from the experiment. Question 15. Redox reactions are common in the chemistry of group 17 elements that are halogens. Which statement is correct? Part A. Bromide ions will reduce chlorine but not iodine. We can write chemical equation to understand this one. Now the reaction is Cl2 if it reacts with sodium bromide. As we know that chlorine is more reactive than bromine, so it will displace bromine to form sodium chloride along with bromine. The oxidation state of chlorine is 0 and in this side it is -1. Similarly, the oxidation state of bromine is -1 and on this side it is 0. For second one, we can write the equation with iodine. Now as we know that iodine is below bromine, so therefore it is unable to displace bromine from sodium bromide. So no reaction will take place. Now in the first one, we can see that chlorine has reduced and bromine has got oxidized. So now we can say that bromide ions can reduce chlorine. This is true, but not iodine. This is also true because the reaction will not take place. Part B. Chlorine will oxidize bromide ions but not iodide ions. Let's write the chemical equation for this reaction. We have chlorine and bromide, so we can write chlorine plus sodium bromide. It is negative. Oxidation state is 0. Now chlorine is more active, so it can displace sodium bromide to sodium chloride. In second equation, we should use iodide ions. So chlorine plus sodium iodide. Again, chlorine is more active, it can displace iodide to form sodium chloride. Now it says chlorine will oxidize bromide ions. Now bromide is oxidized to bromine. This is true. Chlorine also oxidizes iodide to iodine. So this part is incorrect. Part C. Fluorine is the weakest oxidizing agent out of fluorine, chlorine, bromine and iodine. Now as we know, as we move down in the group, the oxidizing power decreases. So fluorine should be the strongest oxidizing agent. This is because fluorine gains electron more easily as compared to chlorine, bromine or iodine. Part D, iodide ions are weakest reducing agents out of fluoride, chloride, bromide and iodide. Now reducing agent is the one that loses electron easily. So iodide will be the one that will lose electron more easily as compared to bromide, chloride or fluoride, because these are more electronegative than iodide. So it should be the strongest reducing agent. Correct option is therefore part A. Question 16. Silver chloride and silver iodide form equilibria when added to water. This is silver chloride, it forms Ag plus and Cl negative, Kc is equal to K1. Silver iodide forms its ions, Kc is represented as K2. Each equilibrium position lies well to the left. It means that these are almost insoluble. Silver iodide will not dissolve in aqueous ammonia. Silver chloride will dissolve in aqueous ammonia. Another equilibrium is formed. Now silver reacts with ammonia to form this aqueous ion. Now this Kc is represented by K3. The position of this equilibrium lies to the right. It means that this is more soluble as more ions will be formed. What is the order of magnitude for these three equilibrium constants? We have to find out which one is the smallest among K1, K2 and K3 and which one is the largest. As Kc is the concentration of product divided by concentration of reactants, it means more soluble product will have higher value of Kc and less soluble salt will have lower value of Kc. As we can see that each equilibrium position lies well to the left, so therefore K1 and K2 is small, and in K3 it says the position of equilibrium lies to the right. It means that the concentration of product is higher. So we can say that K3 is greater than K2 or K1. Now let's decide whether K1 is larger or K2 is larger. As it says, silver iodide will not dissolve in aqueous ammonia. So the ions present will be the same. They are not going to dissolve in aqueous ammonia, while silver chloride will dissolve in aqueous ammonia. If this one, silver chloride, it dissolves in aqueous ammonia, what happens that these ions, they will react with ammonia to form this equation, and there will be a decrease in concentration of silver ions. So when the concentration of silver ions is decreased, the equilibrium will move in the forward direction and therefore more product is formed and Kc will be greater. So therefore we can say that K1 will be greater than K2. This is because K1 is moving in the forward direction while K2 is still in its own place. So now we can see that K3 should be the largest. On second position we have K1 and on third position we have K2. Correct answer is therefore C. Question 17. X is the ion of a metal which burns with a red flame. Y is the ion that reacts with concentrated sulfuric acid to produce hydrogen sulfide gas. What could be the formula of a compound containing X and Y? Now we have barium and we have strontium. You should remember that the flame of barium is apple green in color, while for strontium the flame color is scarlet red. So as it says the red flame should be there, so therefore it should be strontium, not barium. Second thing is that it reacts with concentrated sulfuric acid to produce H2S. Now among bromide and iodide, we know that iodide can react with sulfuric acid to form iodine, H2S and H2O. So it is not bromide, it is iodide. Correct answer is therefore D. Question 18. Oxides of nitrogen are present in the environment due to natural and man-made sources. Which row is correct? First one is the natural sources and second one are the man-made sources. Now in natural sources of nitrogen oxides we have electrical discharges in the atmosphere. This is true. Because in the presence of lightning what happens that nitrogen reacts with oxygen to form oxides. This one is also correct. Decomposition of dead plants in rivers, it forms methane gas, it does not produce nitrogen oxide. Among man-made sources, we can see that internal combustion of engines as the temperature is very high, so therefore nitrogen can react with oxygen to form nitrogen oxides. And as a byproduct of the Haber's process, this is incorrect. Correct answer is therefore part A. Question 19. Magnesium hydroxide dissolves in aqueous ammonium chloride but not in aqueous sodium chloride. Which statement explains this observation? We can understand this question by writing chemical equation. We have magnesium hydroxide. Magnesium hydroxide, it dissolves to form magnesium plus 2 and hydroxide ions. Now the reaction is reversible because magnesium hydroxide is not 100% soluble. Now it says magnesium hydroxide dissolves in ammonium chloride. In ammonium chloride we have, in aqueous ammonium chloride we have ammonium ions, chloride ions that are present. This ammonium ion can react with this hydroxide ion to form ammonia and water. We can write the equation. Ammonium ions, hydroxide ions, they can react to form ammonia and water. Now we can see that NH4 positive has donated a proton to OH negative to form NH3 and OH negative has gained a proton to form H2O. Second thing is that it says magnesium hydroxide does not dissolve in aqueous sodium chloride. So in aqueous sodium chloride we have sodium ions and we have chloride ions. In magnesium hydroxide we have magnesium and hydroxide. So no reaction can take place. Because the products sodium hydroxide and the products magnesium chloride both are highly soluble. Part A, the ionic radius of ammonium ion is similar to that of magnesium plus 2 but not that of sodium plus. So statement 1 is wrong. Part B, ammonium chloride dissociates less fully than sodium chloride. We know that ammonium salts are also fully soluble in water as compared to sodium chloride. That is also fully soluble. So therefore this is also incorrect. Part C, the sodium ion and magnesium plus 2 ions have the same number of electrons. In sodium we have 11 minus 1, 10 electrons. In magnesium we have 12 minus 2, 10 electrons. Now this statement is correct but it has nothing to do with the solubility of magnesium hydroxide because number of electrons does not involve in the solubility. Part D, the ammonium ion can donate a proton. Now we can see that ammonium ions, they can react with OH negative and it will donate its proton to OH negative to form ammonia and water. Now what will happen that this equilibrium will shift in the forward direction because the concentration of OH negative ions decrease. So when it moves in the forward direction, the solubility of magnesium hydroxide will increase. So therefore we can say that magnesium hydroxide dissolves in aqueous ammonium chloride. Correct option is therefore D. Question 20. The formula of hydrocortisone acetate is shown. This is a structure. Which row is correct? We have to find out the number of carbon atoms in one molecule and number of chiral carbon atoms present in one molecule. Let's first count the number of carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So we have 23 number of carbon atoms. Now let's look into the number of chiral carbons. We know that chiral carbon is the one that is attached to 4 different groups or elements. Now this means that the carbon that is attached to 2 hydrogen atom, it is not chiral. The carbon that is attached to 3 hydrogen atom, it is not chiral. The carbon that is making a double bond, it is also not chiral. Let's look into the structure. This carbon is making double bond. This is bonded to 2 hydrogen atoms. This is also bonded to 2 hydrogen atoms. This is making a double bond. And we have this carbon atom that is attached to 4 different groups. As this side is different than this one, we have one CH3 and one this one. So one chiral carbon is present here. Then this has two hydrogens, not chiral. Let's look into this one. We can see that we have one hydrogen atom also present. So this is chiral. Again in this one we have one hydrogen atom present, so this is also chiral. CH3 carbon is not chiral as it is attached to 3 hydrogen atoms. Then again we can see that this carbon is also chiral as we have one hydrogen atom also attached. This is CH2. This carbon is also chiral as it is attached to one hydrogen atom and 3 other groups. This one is also chiral. This is chiral. This is CH2, this is CH2. This is double bonded, this is CH2, this is double bonded to oxygen, this is CH3. So in total we have 7 chiral carbons. Correct option is therefore C. Question 21. Bromomethane CH3Br decomposes in the stratosphere forming methyl free radicals and bromine free radicals. Which row correctly describes this decomposition? We have to find out the type of bond fission and the number of electrons in a bromine free radical. Now we can write the equation. We have CH3Br. It decomposes to form methyl free radicals and bromine free radicals. Now we had one electron that is shared from carbon atom and one electron from bromine atom. In the formation of free radical there is homolytic fission, equal distribution of electrons. Each bonded atom takes one electron. So therefore it is homolytic, not heterolytic. Second thing is bromine radical. As we can see that there is no negative charge, so it means it is overall neutral. So number of protons will be equal to number of electrons. The atomic number of bromine according to periodic table is 35. So there must be 35 protons, or we can say that 35 electrons are present in bromine free radical. Correct answer is part A. Question 22. Structural and stereoisomerism should be taken into account when answering this question. Y is a gaseous hydrocarbon which decolorizes aqueous bromine. It contains no rings. 10 grams of Y occupies a volume of 3.43 decimeter cube under room conditions. How many isomeric structures are possible for Y? As we can see that Y is a gaseous hydrocarbon, so it consists of carbon and hydrogens. It decolorizes aqueous bromine. It means that double bond is present between two carbon atoms, as alkene can decolorize aqueous bromine. It contains no rings, so it means that it could be either straight chain or branched chain. Then we have mass in grams and volume in decimeter cube. We can convert this volume into number of moles, and from number of moles and mass we can find out the molecular mass. As we know that number of moles is equal to volume in decimeter cube divided by 24 decimeter cube. So it is equal to 0.143 mole. Secondly, we can use mass in grams to find out the molecular mass. As number of moles is equal to mass in grams divided by molecular mass, or we can say that molecular mass is equal to mass in grams divided by number of moles. Mass in grams is given, it is 10 grams. Number of moles is calculated, 0.143. So now the molecular mass should be equal to 70. As Y is alkene, now the general formula of alkene is CnH2n. It means if there are 5 carbon atoms, then there should be 10 hydrogen atoms, or the double number of hydrogen atoms as compared to carbon atom. For molecular mass 70, if we have 5 carbon atoms, so 12 5 is equal to 60, and 10 hydrogen atoms, so the molecular mass will be 10, it will come equal to 70. It means that the formula of this alkene is C5H10, or it is pentene. Now let's draw the structural and stereoisomers for this pentene. As we have 5 carbon atoms, 1, 2, 3, 4 and 5. This is pent1ene. No cis-trans isomer is possible as the double bonded carbon is bonded to the same atoms. Both are hydrogen atoms. Let's try another structure for this one. We have pentene. Again, no geometric isomerism is possible. Now we can change this long chain. We had 4 carbon atoms, 5 carbon atoms in the long chain. Now we have 4 and 1 is branched. Similarly, we can change the position of this branched CH3. We can attach it to this carbon atom. Another possibility is that we can change the position of double bond to this carbon atom. As we can see that this is CH3. We have 1 hydrogen with this carbon, 1 hydrogen with this carbon. Now as we can see that the double bonded carbon atoms are attached with different groups on both sides, so therefore it will show cis and it will also show trans isomerism. Now let's move this double bond to a little bit further. We can draw another structure for this one. Again, we have 5 carbon atoms, 1 double bond. And now this cannot show cis-trans isomerism because both groups attached with double bonded carbon are same. So only one is possible. So we have 1, 2, 3, 4, 5 and 6 possible isomers. So correct answer is C. Question 23. Which equation represents a valid propagation step in the chlorination of ethane? In A and B, we can see that we have chlorine free radical that reacts with alkane. Now when chlorine free radical reacts with carbon hydrogen bonds, it always forms HCl. It does not form free radical of hydrogen, and free radical comes on carbon atom. Another thing that you should remember is that hydrogen free radical is not formed in this chemical reaction in which chlorine reacts with alkane. In part D, again we can see that chlorine free radical reacts with free radical and both are converted into product, so therefore this is not propagation, it is termination step. Because in propagation, one free radical generates another free radical. Correct answer is therefore part A. Question 24. Butanoic acid can be made from 1 bromopropane in 2 stages. In stage 1, we can see that we have converted Br into Cn. In stage 2, the Cn that is formed is converted into carboxylic acid. Which types of reactions are stage 1 and stage 2? First one is CH3, CH2, CH2, Br. Bromine is electronegative, carbon is electropositive, and in order to replace this, cyanide will attack this carbon atom and this bromine is removed or it is substituted. As we can see that there is negative charge, so therefore this is nucleophile. This reaction is called nucleophilic substitution reaction. In stage 2, we can see that cyanide is converted into carboxylic acid. Now this is possible when we react cyanide in the presence of HCl. It is refluxed. What happens that this part converts into carboxylic acid and ammonium chloride is formed. So it is hydrolysis reaction. Correct answer is therefore C. Question 25. A halogenoalkane has the molecular formula C5H11Br. The halogenoalkane does not form an alkene when treated with ethanolic sodium hydroxide. What could be the halogenoalkane? When halogenoalkane is treated with ethanolic sodium hydroxide, what happens that hydrogen bromide is removed in the form of H2O and sodium bromide, and also alkene is formed. Let's see which one does not form an alkene or this product. First one is 1-bromo-2-methyl-butane. So we have 4 carbon atoms in the long chain. On first carbon atom we have bromine atom, Br. On second carbon we have methyl group. Now upon reaction with ethanolic sodium hydroxide, what will happen that from one carbon halogen is removed, while from adjacent carbon atom hydrogen will be removed, and there will be double bond between these two. So the product is like this. We have C double bond C, then CH3, C. So one is incorrect as it is forming alkene. Second one is 2-bromo-2-methylbutane. Let's draw. On second carbon atom we have bromine, or on second carbon atom we also have methyl group. On first carbon atom we have 3 hydrogen atoms. On third carbon atom we have 2 hydrogen atoms. Now we can see that from one carbon bromine is removed, and from adjacent carbon, which could be this carbon or it could be this carbon atom, hydrogen will be removed and it will form an alkene. So either this product is formed or this one is formed. Next one is 3-bromopentane. We have 5 carbon atoms in the long chain as it is pentane, and on third carbon atom we have bromine. So either hydrogen is removed from this carbon or from this adjacent carbon. So double bond will come between these two or between these two, and the product will be same. Product will be C, double bond C, then we have single bonds. So the double bond is present on second carbon atom. Again, if we draw between these two carbon atoms, then the double bond will be on second carbon atom. So B and C are also incorrect. Now let's move towards D. We have 1-bromo 2,2-dimethyl-propane. So in total we have 3 carbon atoms as it is propane. On one we have bromo. On second carbon we have 2 methyl groups. So if we remove bromine from one carbon atom, there is no hydrogen atom present on the adjacent carbon. So therefore the product is not going to be formed. This reaction will not take place. Correct option is therefore part D. Question 26. Compound P is heated under reflux with an excess of acidified potassium dichromate 6 to form compound Q. Compound Q has a lower boiling point than compound P. What could be compound P? First one is 2-methylbutane 1-ol. There are 4 carbon atoms in long chain. On first carbon we have alcohol group, so it is primary alcohol. On second carbon atom we have methyl group. So we know that primary alcohol upon oxidation it forms carboxylic acid. Now the boiling point of carboxylic acid is always higher than the boiling point of alcohol. This is because of the presence of hydrogen bonding, and we have 2 electronegative oxygen atoms present. So A is incorrect. B is 2-methylbutane 2-ol. On second carbon atom we have methyl functional group. Also on second carbon atom we have alcohol functional group. Now we can see that this OH is attached with this carbon atom, which is directly attached to 3 other carbon atoms. So this is tertiary alcohol. And tertiary alcohol does not get oxidized. No product is formed. So this is incorrect. Part C is pentane 1-ol and part D is pentane 2-ol. So for 1-ol it means it is primary alcohol. For 2-ol it means it is secondary alcohol. Now again, as was the first case, this one is oxidized into carboxylic acid. We have 5 carbon atoms, it will form pentanoic acid, 5 carbon carboxylic acid. This one is secondary alcohol because this carbon is attached directly to 2 carbon atoms. So this will be oxidized to ketone. Secondary alcohol always oxidizes to ketone. Now in ketone we can see that the electronegative oxygen is not bonded to any hydrogen atom, so therefore hydrogen bonding is absent. While in primary alcohol or secondary alcohol there is always hydrogen bonding, as electronegative oxygen is directly attached with the hydrogen atom, so the boiling point will be less for this one. So therefore correct answer is D. Question 27. Structural and stereoisomerism should be taken into account when answering this question. An organic compound X is dehydrated by heating with concentrated phosphoric 5 acid. Only 2 organic products are formed. What could be X? Dehydration means removal of water. It will be removed in such a way that OH is removed from one carbon atom and hydrogen is removed from adjacent carbon atom. Now as we can see that this carbon atom is attached with OH and hydrogen atom can be removed from either this carbon atom Let's draw the product. We have CH3. Then we have CH as one hydrogen is removed. Then there will be double bond between these two carbon atoms as OH is removed from this carbon and hydrogen is removed from this carbon atom. Then we have CH2 and then we have CH3. Again, similar product is formed if we remove this hydrogen atom and this OH because the double bond will come between these two carbon atoms. We can write the product CH3. Then we have this CH2. Then this carbon gets OH removed. Then we have double bond. Then CH. And then CH3. As both are the same, we can see that double bond is between second and third carbon atom. From this one, the numbering will start from this end as double bond is nearer. So the double bond is between second and third carbon atom. Both will be considered as single product. As we can see that this carbon atom is bonded to hydrogen, it is also bonded to CH3. Similarly, on this side, this carbon atom is bonded to hydrogen and it is also bonded to CH2CH3. So therefore, one product will be cis and one product will be trans. So two different products are formed upon dehydration of A. So A could be correct. Similarly, we can do this one. Either hydrogen is removed from this carbon atom along with OH or hydrogen is removed from this adjacent carbon atom along with OH. So let's draw the two products. We have CH3, CH2. Then if this hydrogen is removed, it will be CH. And double bond will come between these two carbon atoms. OH is removed. Then we have CH3. We have double bond between second and third carbon atom, and this carbon atom has hydrogen and CH3CH2 group. This carbon atom has hydrogen and CH3 group, so it will show cis and trans isomerism. So we have already formed two products, one is cis, one is trans. Let's draw the second product. In the second product, we can use these two. Now we have CH3CH2. Then again CH2, CH. Now double bond will be between these two carbon atoms. Now as we can see that the double bond is in between first and second carbon atom, so this is different than this product. And with this carbon, both hydrogen atoms are attached, so therefore it will not show cis-trans isomerism. So three products are formed, one is this one is this one, and one is this product. So B is incorrect. Looking at part C, we have OH group attached with this carbon atom, and hydrogen can be removed either from this adjacent carbon atom or this adjacent carbon atom or this adjacent carbon atom. So we can draw three products. In first one, we are going to remove this hydrogen atom. So we have CH3, then CH, then double bond will come between these two carbon atoms. Then we have CH3 substituent, then again CH2 and CH3. Now the double bond is in between second and third carbon atom, and we have hydrogen and CH3 on one side and CH3 to CH3 on the other side, so therefore this will show cis and trans. So two products are formed. Now if we remove this hydrogen atom along with OH, then the product will be like this: CH3, CH2, then we have this carbon atom, and it will form double bond with the substituent, then CH2 and CH3. Now double bond is in between first and second carbon atom, and as the double bonded carbon atom is attached with two hydrogens, so therefore this will not show cis-trans isomerism, only one product is seen. So we already have more than two products, one is cis, one is trans, and one is this one, so therefore this is also incorrect. Now next one is part D. We have OH group and we have hydrogen on this side and hydrogen on this side. Again we have OH group and hydrogen on this side and hydrogen with this carbonate. We can draw this skeletal formula. If OH is removed and hydrogen is removed from first and second carbon atom, then double bond will come between these two carbon atoms. Again on the same reaction we have OH and this hydrogen removed, so then double bond will come between these two carbon atoms. So this is one product. We have double bond between first and second and third and fourth carbon. Another possibility is that now we can remove hydrogen and OH from first and second carbon, and we can remove this hydrogen and this OH between second and third carbon. Product will be like this, and double bond is in between first and second and third carbon. So now two products are formed. Third possibility is that we can remove this OH along with this hydrogen and this OH along with this hydrogen. So there will be double bond between these two carbon atoms and double bond between these two carbon atoms. The product will be like this. Now we have double bond between second and third and fourth carbon atom. Already more than two products are formed, so therefore this is also incorrect. Correct option is therefore A. Question 28. Which compound produces a precipitate with 2,4-dinitrophenylhydrazine reagent and also with alkaline aqueous iodine? Now you should remember that 2,4-D-NPH can react with aldehydes. It can also react with ketones. Alkaline aqueous iodine only reacts with those aldehyde or ketones that have CH3 group directly attached to the carbonyl carbon, or those alcohols in which CH3 group is directly attached with the carbon having OH. First one is butane 2-ol, as this is alcohol, so therefore it will not give a precipitate with 2,4-D-NPH, as only aldehyde and ketone can give this product. Second is butanol. This is aldehyde, so therefore this will show reaction with 2,4-D-NPH. Let's see whether it will give with alkaline aqueous iodine or not. Butanol is 4-carbon aldehyde. As we can see that CH3 group is not directly attached with carbonyl carbon, so therefore this will not give precipitate with alkaline aqueous iodine. Third one is butanone, which is ketone. It will give reaction with 2,4-D-NPH. Let's draw the structure. Now we can see that CH3 is directly attached to the carbonyl carbon, so therefore this will also give result with alkaline aqueous iodine. D is pentane 3-on. In this ketone we have carbonyl carbon on third carbon atom. As we can see that CH3 is not directly attached to carbonyl carbon, so therefore this will not give result with alkaline aqueous iodine. Only 2,4-D-NPH will be positive. Correct answer is therefore part C. Question 29. Organic compound Z has an alcohol group and a carboxylic acid group. Compound Z reacts with magnesium carbonate to make a salt with relative formula mass of 230.3. Compound Z does not react with acidified potassium manganate. What could be the identity of compound Z? Now we know that only that alcohol which is tertiary alcohol, it does not gets oxidized. So therefore it means that organic compound Z should be tertiary alcohol. And tertiary alcohol is the one in which carbon atom attached with OH group is further attached directly with 3 other carbon atoms. Let's draw the structures of all these 4. First one is 2-hydroxy 2-methyl butanoic acid. We have 4 carbon atoms. Now we have hydroxy group on second carbon atom and methyl group is also attached on second carbon atom. This is first carbon, this is second carbon. We have OH group and methyl group. Now we can see that this carbon is directly attached with 3 other carbon atoms, so therefore it means it is tertiary alcohol. So it will not oxidize with acidified potassium manganate. Second one is 2-hydroxy 2-methyl propanoic acid. We have 3 carbon atoms in the long chain. On second carbon we have hydroxy and methyl, OH, CH3. Again this is tertiary alcohol as this carbon is directly attached to 3 other carbon atoms. Then we have 3-hydroxy 2-methyl butanoic acid. Again we have 4 carbon carboxylic acid. On third carbon atom we have hydroxy and on second carbon atom we have methyl. Now we can see that in this alcohol this carbon is directly attached to 2 other carbon atoms, which means it is secondary alcohol and it will get oxidized with potassium manganate to form ketone. Therefore C is incorrect. Now drawing part D, we have 3-hydroxy 2-methyl propanoic acid, 3 carbon atoms in the long chain. On third carbon we have hydroxy and on second carbon we have methyl. Now this is primary alcohol and it will be oxidized as this carbon is only attached directly with 1 carbon atom, so this is also incorrect. Now among A and B, we can find out which reacts with magnesium carbonate to make a salt with relative formula mass of 230.3. Now in magnesium carbonate we have Mg plus 2, while in carboxylic acid group we have COO negative. It means that 2 carboxylic acid will be needed for 1 magnesium atom to balance the charges. Let's find out the molecular mass of this part and we can multiply it by 2. We have 3 hydrogen with this carbon, 2 hydrogen with this carbon. In total we have 5 carbons, 10 hydrogens, 3 oxygen atoms, and the charge will be negative as this hydrogen will be lost when it reacts with magnesium carbonate. Let's find the molecular mass. 12 into 5 is 60, plus we have 10 hydrogen, plus 16 into 3 is 48. So the molecular mass comes equal to 118. This is for one negative part, as we have 2 negative carboxylic acid with 1 magnesium, so multiply by 2, 236, plus the molecular mass of magnesium, which is 24.3. So it comes equal to 260.3, which is not equal to 230.3, so therefore this is wrong. Now looking at part B, we have this structure. When it reacts with magnesium, we have negative charge on this side, then we have Mg plus 2. And again this group should be present on the other side as the charges should be balanced. So we have O negative, then C double bond O, then carbon with OH, and CH3, then CH3. The charge is negative. We can count the number of carbons. We have 4 carbon atoms on this side, 7 hydrogen atoms, 3 oxygen atoms, and we have negative charge. So let's find the molecular mass. 12 into 4 is 48, plus 7 for 7 hydrogen, plus 16 3 is 48 for 3 oxygen. So it comes equal to 103. Similarly, 103 will be on this side as the formula mass is same. So 103 plus 103 plus the molecular mass of magnesium, which is 24.3. It comes equal to 230.3. Correct option is therefore part B. Question 30. The infrared spectrum of Y is shown. We can see the infrared spectrum. What could Y be? In this spectrum, we can see that there is no carbonyl carbon peak. If there is no carbonyl carbon peak, it means aldehyde, ketone, carboxylic acid, ester, and amide, they are absent. Let's look into the option. First one is ester, as we have CH3, then we have C double bond O carbonyl carbon, then oxygen, and then C2H5. So this is incorrect as carbonyl peak is absent. In second one, we have alkene and alcohol functional group. So it could be this one as no carbonyl is present. In third one, we can see we have carboxylic acid. So we have CH3, CH2, CH2, C double bond O, OH. Again, carbonyl carbon is present in this one. So this is also incorrect. In the last one, we can see we have aldehyde functional group. So in aldehyde functional group, we have C double bond O, H. Again, carbonyl peak should be present. So this one is also incorrect. In part B, we have alcohol functional group on both sides, and this peak is because of the presence of alcohol, as it is between 3200 to 3600 strong peak. It indicates alcohol functional group. Therefore, correct option is part B. Question 31. The Boltzmann distribution diagram shows a fixed amount of gas at two different temperatures, T1 and T2. This is T1 peak and this is T2. And this is the activation energy that is shown. Which statements correctly describe the features of this diagram? Number 1. Temperature T1 is lower than temperature T2. Now this is correct because when temperature is increased, the peak moves in the forward direction as the average molecular energy increases. Part 2. The shaded area indicates the particles that have sufficient energy to react at T2. This is the shaded region. And as the energy of molecules have energy more than activation energy, so therefore this area shows the particles that have sufficient energy to react. Part 3. The total area under each curve is same for both temperatures. As in the question, they have given that we have fixed amount of gas. So for fixed amount of gas, the number of molecules are same on both curves, T1 and T2. So when number of molecules is same, it means that the area under the curve is also same. All three options are correct, therefore answer is A. Question 32. 4 solutions, each of concentration 0.1 mole per decimeter cube, were tested with the pH meter. The results are shown. We have pH 4, 1, 11 and 14. Which statement explains these results? We can draw the pH line. Now stronger acid means we have lower pH. Or we can say that at lower pH we have more H plus ion concentration. Similarly, for higher pH we can say that moving to this side we have higher pH, or we can say that we have more OH negative ion concentration. Let's move towards the option. In first one it says acid 2 has a lower pH than acid 1. Yes, it is lower than acid 1 because it is more soluble. Now this statement seems true, but the solubility does not change the pH. Some salts are soluble but their pH is 7. So therefore we cannot say that this is true. It should be because it has more H positive ions. Because pH depends on the concentration of H positive ions. Greater the number of H positive ions, greater will be the pH. So 1 is incorrect. Second one, base 2 has higher concentration of hydroxide ions in solution than base 1. As pH of base 2 is more, so more pH means more hydroxide. And we have base 1 whose pH is 11, so it means it has less number of hydroxide ions. So this is the correct option. Part 3, acid 1 dissociates less than acid 2. As we can see that pH of acid 1 is greater than acid 2, and as acid 2 is strong acid, it is nitric acid, while acetic acid is comparatively weak acid. So strong acid is the one that dissociates fully, while weak acid is the one that dissociates partially or less. Option 2 and 3 are correct, therefore answer is C. Question 33. Which reactions are redox reactions? Now redox are those reactions in which reduction and oxidation both take place at the same time. We can find it by finding the oxidation states. For oxidation state of element we know it is 0. In HCl hydrogen is +1, Cl is -1. In magnesium chloride, as magnesium belongs to group 2, so the oxidation state is +2. For one chlorine atom it will be -1. Hydrogen is a molecule, so the oxidation state is 0. Now we can see that magnesium has turned from 0 to +2, so magnesium goes to oxidation. While H plus has converted into 0 oxidation state, so therefore this is reduction. So option 1 is correct. Now let's find the oxidation state in second one. We have potassium. Potassium is +1. It has not changed. H plus has +1 oxidation state on the reactant side, and in water again it has +1 oxidation state because oxygen is -2 and there are 2 hydrogen atoms. Each one will have +1 charge. This one is also +1. The oxidation state of oxygen does not change. It is -2 in the reactant side and -2 in the product side. We can also find the oxidation state of chromium on the reactant and product side. First one is K2CrO4. Second one is K2Cr2O7. We have 2 potassium. For 1 potassium it is +1, for 2 it will be +2. We have chromium, we have 4 oxygen, so it will be -8 for 4. Overall charge is 0. So chromium -6 equals 0. Chromium will be +6. Similarly, on this side we have 2 potassium, so it is plus 2, 2 chromium. For 7 oxygen it is negative 14, overall charge is 0. So 2 chromium minus 12 equals 0. 2 chromium equals plus 12, or 1 chromium equals plus 6. So there is no change in oxidation state even for chromium. Therefore, option 2 is wrong. Let's look into the third one. We have copper carbonate, HCl. In copper carbonate, copper is plus 2. In copper chloride, again copper is plus 2. No change has taken place. In HCl, we have plus 1 for hydrogen, negative 1 for chlorine. In water, plus 1 for hydrogen, negative 2 for oxygen. In carbon dioxide, plus 4 for carbon, negative 2 for oxygen. Now we can see that there is no change in oxidation states. We can confirm the oxidation states of carbon in both these compounds. We have copper carbonate, we have carbon dioxide, copper is plus 2, oxygen is minus 2, so for 3 oxygen it will be minus 6, overall charge is 0, so carbon minus 4 equals 0, carbon is plus 4 on the right hand side. Similarly, in carbon dioxide we have 2 oxygen atoms, so carbon minus 4 equals overall charge, which is 0, carbon equals plus 4. So there is no change in oxidation state of carbon. Again, 3 is also not a redox reaction. As only option 1 is correct, therefore answer is D. Question 34. When liquid N2F4 is heated, it decomposes into single product X. Which statement are correct? We can draw the structure of N2F4. We have 4 fluorine atoms. As we know that nitrogen makes 3 maximum single covalent bonds. So the structure could be like this. Now it says N2F4 upon heating decomposes into single product X. So we can decompose it from here. NF2, single product NF2 is formed. Number 1, NF bonds are broken during this decomposition. As we can see that nitrogen-nitrogen bond is decomposed, so this is incorrect. Number 2, the enthalpy change when N2F4 decomposes into X is approximately 160 kilojoules per mole. From data booklet we can see that the bond energy associated with the breaking of nitrogen-nitrogen single bond is 160 kilojoules per mole. As we can see that only nitrogen-nitrogen single bond is broken, so therefore this option is correct. Number 3, molecules of X are non-linear. The molecule of X is NF2. Nitrogen has lone pair of electrons. And we have 2 fluorine atoms. So due to the presence of lone pair, the structure will be bent, it will not be linear. As option 2 and 3 are correct, therefore answer is C. Question 35. The following statements compare some properties of the oxides and chlorides of sodium and silicon. Which statements are correct? For sodium, we have sodium oxide Na2O. For sodium, we have sodium chloride, that is NaCl. For silicon, we have silicon dioxide SiO2 and we have silicon chloride SiCl4. First one, the melting point of SiCl4 is higher than the melting point of SiO2. Now in SiO2 we have giant structure in which each silicon is bonded to 4 oxygen atoms and each oxygen atom is again bonded to 2 silicon atoms, and this structure continues. While in SiCl4 we only have 4 chlorine atoms around single silicon. So this is simple molecular, this is giant molecular. So the melting point of SiO2 should be higher than the melting point of SiCl4. Option 2, SiCl4 reacts with water, NaCl does not. Now we can write the equation. SiCl4 when reacted with water, it forms SiO2 along with HCl. While NaCl does not react with water, it only dissociates into its respective ions, Na positive and Cl negative. So therefore statement 2 is correct. Option 3, the melting point of SiCl4 is lower than the melting point of NaCl. This is true because in NaCl we have ionic bonding and the melting point is quite high. While in SiCl4 we have simple molecular structure. As option 2 and 3 are correct, answer is therefore C. Question 36. Which statements about ammonium chloride are correct? First one is that it reacts with hot aqueous sodium hydroxide to produce an alkaline gas. We know that ammonium chloride is ammonium salt and ammonium salt reacts with alkali to form ammonia gas. It forms salt, water and releases ammonia. So option 1 is correct. Option 2, in solution it reacts with aqueous silver nitrate to produce a white precipitate. Ammonium chloride is ammonium and chloride. Silver nitrate is AgNO3. Now it can react to form AgCl, which is silver precipitate. Option 2 is also correct. Option 3, when solid, it reacts with concentrated sulfuric acid to produce chlorine. This is incorrect because in ammonium chloride we have chloride which are unable to reduce sulfuric acid. Iodide ions can only reduce sulfuric acid. As option 1 and 2 are correct, answer is therefore B. Question 37. What is same for a pair of optical isomers? Let's draw an optical isomer. We have carbon, CH3, OH, hydrogen, COOH. Its optical isomer will be the mirror image. As we can see that nothing has changed, only orientation has changed. These are the mirror images. So their empirical formula is same, their functional groups are same, their structural formula is same, only the orientation changes in 3 dimensions. As all 3 options are correct, therefore answer is A. Question 38. Which of the molecular formula represent at least one compound that can undergo addition polymerization? For addition polymerization, if we have double bond between 2 carbon atoms, then they can undergo addition polymerization. Let's look into the first one. First one is alkene, C4H8. We can draw the structure 1, 2, 3, 4. So this can undergo addition polymerization through these 2 carbon atoms. The repeat unit will be like this. We have CC, CH2, CH3, hydrogen, H and H. In second one, we have 2 carbon, 3 hydrogens and 1 chlorine. Let's draw the structure. We have 2 carbons, 3 hydrogen atoms, and 1 chlorine atom. Now there must be a double bond because each carbon makes 4 bonds. So as double bond is present, it can also undergo addition polymerization. And the repeat unit will be like this. We have carbon, carbon single, H, H and HCl. Let's look into the third one. We have 3 carbon atoms, 6 hydrogen atoms, 1 oxygen atom. There could be a double bond between these 2 carbons. So it can also undergo addition polymerization by these 2 carbon atoms. The repeat unit will be like this. As all 3 options are correct, therefore answer is A. Question 39. Which of the reactions give products containing a chiral center? Let's do the reactions. First one is CH2OH, C double bond O, COOH. Excess of HCN. CN will attack this partial positive carbon atom. And the product formed will be like this. This oxygen will attack another HCN to form OH. Now we can see that with this carbon atom we have 4 different groups attached. One is OH, one is CN, one is COOH and one is CH2OH. So therefore the product is chiral. Second one is CH2OH, CO2H in NaBH4. Now sodium borohydride or NaBH4, it can reduce ketone into secondary alcohol. So this carbonyl carbon will be converted into secondary alcohol functional group. The product will be like this. Again we can see that with this carbon we have 4 different groups attached. So therefore the product is chiral. In third option we have excess of lithium aluminum hydride. Again this is reducing agent. It reduces ketone to secondary alcohol and it also reduces carboxylic acid to primary alcohol. Let's do this one. Now both will be reduced, this one and this one. We have primary alcohol on first carbon. We have ketone that is converted into secondary alcohol group. Carboxylic acid will be converted into primary alcohol. Looking at the central carbon atom, we can see that these 2 groups are same. So therefore the product is not chiral. As option 1 and 2 are correct, answer is therefore B. Question 40. Ethyl butanoate is heated with dilute aqueous solution of sodium hydroxide. Which substance are products of this reaction? Let's draw ethyl butanoate. We have 4 carbon atoms and we have C2H5 attached, and this is ester. We have this structure. This is ethyl part, and these 4 carbon atoms represent the butanoate part. Now we are going to react it with dilute aqueous solution of sodium hydroxide. It means alkaline hydrolysis will take place. Now upon alkaline hydrolysis, what will happen that one part is converted into alcohol, while second part, the carbonyl part, is converted into sodium salt. So the product is like this: CH3, CH2, CH2, COO, Na. While this part is converted into alcohol, we have CH3, CH2, OH. We have 4 carbon atoms and we have sodium, so this is sodium butanoate. And second product is ethanol. So sodium butanoate is true. We have water as a product. This is wrong. Sodium ethanoate is also not formed. As only option 1 is correct, answer is therefore D. Thanks for watching. If this was useful, please do like, subscribe and share.